everyone, welcome to group 3. In this video, we will explain the logical inference assignment from season 7 of the Informatics course. So before that, let me introduce myself. Starting from me, my name is MUHAMAD ANDHIKA. Here I will explain about modus ponens. Modus ponens is a very important important rule in propositional logic. This rule allows you to conclude a statement if you know that another statement is true and that the implication of the first statement to the second statement is also true. Let's see the formula as shown in the picture. Modus ponens takes two premises and one conclusion. If we have a P then Q and P is true, premise 1 P then Q and premise 2 P is true, then the conclusion is that Q must be true. I will give example in statement and sentence such as if it's rain today, then the road is wet. So premise 2P is true, then the conclusion is that the road is wet.
Hello guys, today let's discuss about conjunction. So what is conjunction? The definition is a compound statement formed by joining two prepositions. The using logical operator is AND, the conditional of truth. The entire conjunction is true only when the both of the individual prepositions are true simultaneously. So the logical symbol is P and Q. This is a logical operator. Then simple meaning of both condition must be heard. Since conjunction is a gate that requires two keys to open. If either key is missing, the gate remains closed. For example, condition P must be true, condition Q must be true. The conjunction P and Q results is true. Okay, for an example 1, preposition P, it is raining. Preposition Q, I have an umbrella. Finally, the conjunction is P and Q. It is raining and I have an umbrella. The statement is only true if you check outside and both raining is falling and you physically possess an umbrella. If it's raining but you forgot your umbrella, the conjunction is false. For example 2, the light is on, the fan is running. The combined statement is P and Q. The light is on and the fan is running. If the light is off but this fan is running, the conjunction is false. Example 3, preposition P, I study. Preposition Q, I pass the exam. The conjunction is P and Q. I study and I pass the exam. For the whole statement P and Q to be true, you must both engage in studying and successfully achieving a passing score. Failing the exam, even after studying, makes the conjunction is false. For an example 3, conjunctions are frequently used in mathematics to define sets of numbers that satisfy multiple set criteria. So P, the number is even. The number is even. Q, the number is greater than 10. So conjunction P and Q, the number is even and greater than 10. Then the number 12 makes this statement true. 12 is even, but 12 greater than 10. The number 7 makes it false, 7 not even number. So number 8 is make it false. 8 is even, but 8 less than or equal to 10. Okay, the last example. Preposition P, Ali is a student. And preposition Q always like met. So the conjunction is P and Q. Ali is a student and like met. Okay, the summary of conjunction, key takeaways, operator. The operator, logic operator is conjunction is and. This is and. This is a symbol of and. Truth condition. The conjunction P and Q is only true if both preposition P and preposition Q are true. Application. Use defined condition where multiple requirements must be met simultaneously, crucial for programming and formal proof. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name Muhammad TUSAN GUNAWAN. Today I will explain about modulus tollens. Yeah. Okay, let's start. Modulus tollens is one of the fundamental forms of deductive reasoning used to draw conclusion by examining the logical relationship between a cause and its consequence. The term modus tollens comes from Latin, meaning the way that denies by denying. In logical reasoning, it refers to a pattern used to disprove an initial statement. When the expected result or consequence of that statement is found to be false. Okay. The basic structure of modulus tollens consists of two premises and one conclusion. It operates by denying the consequence, the parenthesis PQ. Parenthesis. The basic structure of modulus tollens consists of two premises and one conclusion. It operates by denying the consequence, parenthesis Q, to conclude that the antecedent, parenthesis P, must also be false. Symbolically, it is expressed as if P then Q, even not Q, therefore not P. Or informal logic notation is P then Q, not Q, therefore not P. The explanation P then Q means if P then Q, and not Q means not Q. The therefore not P means therefore not P. This structure tells us that if the consequence of a condition doesn't occur, then the condition itself cannot be true. For example, premise 1, if it rains, P, then the street will be wet, Q. The premise 1 is the street is not wet, it means not Q. The conclusion is, therefore, it didn't rain, not P. The logical form is, if it then Q, not Q, therefore not P. For example, the second example, premise 1, if the laptop runs out of battery, P, then the screen will turn off, Q. The premise 2 is the screen is not off, not Q. It means the conclusion is, therefore, the laptop didn't run out of battery, it means not P. Okay, the conclusion of modus tollens is that if the accepted result or consequence of a condition P does not occur, then the logical condition P must be false. In other words, modus tollens allows us to disprove a hypothesis by showing that its predicted outcome didn't happen. This reasoning pattern is often used in logic, science, and everyday decision making to eliminate incorrect assumptions and verify the truth of statement through evidence and observation. Okay, thank you so much for everything. Bye-bye.
Constructive dilemma in logical informatics. A constructive dilemma is a logical argument from that combines two conditional if-then statement and a disjunction either or between there and the if part. It concludes with a disjunction between the consequence, the then part. Basic structure of a constructive dilemma from in logic symbol. P if then Q or N R if then S. P or R simpulan Q or S. If you study hard P, then you will get good grades. Q. If you cheat on the test R, then the teacher will punish you as you will either study hard or cheat. P or R. Simpulan ya. You will either get good grades or be punished. Q or S. If you add a lot P, then you will feel full. If you skip meal R, then you will feel hungry as you will either eat a lot or skip meal. P or R. You will either feel full or hungry if Q or S. S. Conclusion of constructive dilemma. A constructive dilemma is a valid from logical reason where two conditional statements if then are given a choice either or is made between their conditional as a relation choice either or must also hold true between their outcomes.
Hello everyone. So today I'm going to explain about hypothetical syllogism. This is the most interesting parts of logical reasoning, and don't worry, it might sound complicated, but it's actually simple once you get the idea. So let's dive into it. So, what is hypothetical syllogism? Well, it is a type of logical argument that connects two if-then statements to form a conclusion. Let's take a look at the basic structure. So if we have two statements, the first one is if P then Q, and then the second one is if Q then R. The conclusion is therefore if P then R. Well, we call this a chain of reasoning because each statement link to the next. Let's take a look at the first example. This is the one example that you can relate to. The first statement is if it rains, then the ground gets wet. And the second statement is if the ground gets wet, then the kids cannot play outside. The conclusion is therefore, if it rains, then the kids can't play outside. So, see, we connected the first if then with the second one, and we got a logical conclusion. Let's take a look at another example. So we have also two statements and one conclusion. The first statement is if I study hard, then I will understand the lesson. Second statement is if I understand the lesson, then I will pass the exam. So the conclusion is therefore, if I study hard, then I will pass the exam. That's a perfect hypothetical syllogism. So, to sum it up, hypothetical syllogism is all about linking two conditional statements to reach a new conclusion. Just remember this simple pattern. If P then Q and if Q then R, then the conclusion is P then R. It's logic, smooth, neat, and powerful. That's all, guys. Thanks for watching, and don't forget, if you practice logic, then your reasoning will get stronger. See you next time. Bye bye.